So welcome everybody to this latest video on 162 Maths, and in this video will be the first part of going over circle theorems, and in this video we'll be covering the arrow, the bow and the Acylic Quadrilateral. So when you have a polygon inside a circle or a tangent to a circle, there are certain properties related to the interior and exterior angles and the lengths. These are known as the circle theorems. Now, not only do you need to be able to recognize them, you also need to be able to quote their definitions, and this will definitely be the case when you're asked to prove or show that angles are what they are. Now, just before we get started, let's just have a look at some general angle notation. Now, if I want to describe this angle here, I'm just highlighting in blue, then I can represent that using either A, O, B, so the three letters. That first letter is what I start at, goes to the middle letter and then to the end letter, and I can have that as a little with a little hat on top, so that represents that angle there. Or I could represent this as drawing a little angle and then my three letters. So again, either of those would be absolutely sufficient. I wouldn't label it as angle O, and I also wouldn't be too concerned about, well, isn't that angle, the blue angle, the same as this reflex angle that I've noted here. Now, typically if you are actually wanting that sort of purplish angle, then you would state the reflex angle, or you would state the acute angle or the obtuse angle, whichever floats your boat. Now, in terms of lengths, we can represent length by just simply writing the two letters together. So when there is no symbol, sometimes they can have a line next to it like that, but again, personally speaking, I certainly wouldn't have an arrow because that would represent vectors. But in terms of just representing the line that connects, or the segment that connects E to F, just write the two letters joined together. Now, the first circle theorem that we'll look at is the arrow, or the arrowhead. Now, this is where the angle at the center of this arrow is always double the angle at the point in the center. Now, the proper definition is, which is what you wanted to quote. So if you were ever asked to give a reason as to why the angle outside the arrow is twice the size of the angle opposite inside, then this is the definition you would need. Now, the only word that I know that a lot of students struggle with is the word subtended, which basically just kind of means that it's just lying on that particular point. So here, the angle subtended at the center, which is this angle here, is twice the angle as the angle subtended at the circumference. So that's basically what this angle here is going to be. So whatever that is, that's going to be double off. So representing this algebra, if that's going to be x, then this angle here would therefore be 2x, and vice versa. If I know the blue angle, then I know that to work out the purple angle, I just need to divide that by 2. But this is definitely one thing that you're definitely going to need to learn, and if it doesn't make sense, as long as you recognize that that is the actual definition of an arrowhead and what is going to be expected in exams. So let's have a look at some example questions that involve the arrowhead. So one thing that, particularly with circle theorems, is you need to be able to recognize and be able to see all of these theorems. Now, there's probably going to be about 6 or 7 theorems that we're going to go through, so it's important that you're able to spot it, because there's going to be no indication in the question to tell you which theorem you're going to need to be using. So you just need to be able to recognize, and how you do that is by practicing questions. So these ones all refer to the arrowhead. So if I start with question A, so here I need to work out the angles of y and x. Now here I know that if this angle here is going to be 98, then this angle here is going to be half of that. So here I've got y equals, and that's going to be 49 degrees. Now typically what you find is when you have got an angle question and you've got multiple letters, you kind of want to answer them in alphabetical order. However, that may not be the case, as you can see, because I've worked out y first. But if I wanted to work out x, I'm not actually using any circle theorems. What I am using is that angles around a point add up to 360. So to work this one out, well, let's just do some, if I want to show some working out, so that would be 98 divided by 2. And to work out x, what I need to do is do 360 minus 98, which is going to give me 262 degrees. Then for b, let's just put a line through that. Then for b, again, I'm working out the same sort of angles. So angle x first, well, that's going to be double of 54, which is going to be 108. And then working out y, well, that's going to be 360 take away from 108, which is going to give me an answer of 252 degrees. Now again, these questions could easily appear on both the calculator and the non-calculator paper. It's just something that you're just going to have to work with. So here what I need to do with C is, again, I'm going to work with x first. Now I know that x lies on the circle with that 240 degrees, so all I've got to do is 360, take away 242, and that gives me an answer of 118 degrees. Now to work out y, well if that's 118, y is going to be half of that, so it's going to be 118 divided by 2, which gives me an answer of 59 degrees. And finally, with regards to question D, so here I've got to work out, well I can work out what angle x is, because I'm going to do it in alphabetical order. So here I know angles on a straight line add up to 180. So here to work out x, I've just got to do 180, take away 127, so that's going to give me an answer of 53 degrees. Then if I know that that's 53, I know that y is going to be double that, so that's going to be 106 degrees, and there I've answered my questions. Now if I was asked to prove or give a reason as to why those angles were, then again just kind of going up, what I would have to do is quote this circle theorem. And that's exactly what, and again it might be hard to believe, but the examiners will be expecting that definition word for word or something of that ilk. So let's move on to the next circle theorem, which is looking at the bow. So this is where the angles at the top and at the bottom remain equal. And again, the proper definition, again, which is what you're wanting to quote, is that angles subtended at the circumference, sharing the same arc are going to be equal. So basically what that means is that this here is going to be equal to this angle here, and this angle here is going to be equal to this angle here. Now you might think if you rotated it, would the opposite angles equal the same? So would ever this angle equal the same, be equal to this one? Well no, because we're looking at these sort of other arcs. So it's where the bow is. So if you imagine that's the center, you're looking for where these two bits here join rather than the two that are joined by a segment. So let's have a look at put these into practice. So let's have a look at working these questions out. So again here, if this angle here is 64, then this angle here would also be 64, so x equals 64 degrees. Likewise for B, if this angle here is going to be the same as this angle here, and this angle here is going to be the same as that angle there, so in this particular question x is going to equal 41 degrees. Then moving on to question C, so again if I just mark which angles are going to be the same, so those two are going to be the same, and these two here are going to be the same by the definition of the bow. So looking at angle, so here I've got U, V, W, X, trying to remember my alphabet. So working with U first, well that's going to be the same as angle C, or the angle at C, so that's going to be 47. Angle V is going to be the same as angle A, so that's 35. Then working with angles in a triangle, well, if I just label these, so if I label this as 47 and label this as 35, well, X and W are going to be the same because they're opposite angles. So all I need to do is do 180, take away 35, take away 47, and I get an angle of 98. So both of those two angles are going to be the same. And again, why? Because they are opposite. So again, it's always important that you remember even the basic rules of angles on parallel lines, angles at point, angles on the straight line, etc. Because all of this will come in with regards to, just because it's in a circle doesn't mean you're not going to be using those rules as well. So moving on to D, again what I'm going to do is mark which angles I can see above. So I'm just going to start off by marking which ones are going to be the same and hope that that helps me. And again with this question I've got the letters of U, V, W, X, also got a fifth angle of a Y. So in terms of U, that's going to be equal to 45 degrees, again because of the bow. Then working out what V is, well again that's opposite to the 94, so that's going to be 94 as well. And again what you might find easy is if you label as you go along, so that's going to be 45. And then obviously then working out what W is, well W is in a triangle with ADY, so all I then need to do is just take away those two angles from 180, in which I get an answer of 41 degrees. So if W is 41, that means X is going to be 41. And then working with Y, well I know that that lies on a straight line, so that's got to add up to 180. So then Y is going to be 180, take away 94, which gives me an answer of 86 degrees. Then working with question E. So again, I'm going to start by colouring in the similar angles. And then from this, again, working with in alphabetical order, x, well, x lies on a straight line with 118. So then all I need to do then is 118, take away 118, which gives me an answer of 62 degrees. And obviously here, x and y are going to be the same. So that's also going to be 62 degrees. Then finally with F on this circle theorem, so again I've got the letters of U, V, W, X and Y and Z in this one. Lots of angles to find. So again, working in alphabetical order, let's start by colouring in the angles in the bow that are going to be the same. And I can also see straight lines, so I'm assuming that I'm going to be using 180 degrees. So working out U first, I'm going to do 180, take away 135, which gives me an answer of 45. So if U is 45, that means W is going to be 45. Then working with V, that's 180, take away 142 because it lies on a straight line, so that's going to be 38. And if V is 38, that means X is also going to be 38 degrees. Again, just marking those, so that's 38, 38, W is 45, this is 45. So then working out what Y is, again you can see a triangle with A, Z and B. Well, not Z, but in terms of the centre point. So here I've got to do 180, take away 38, take away 45, gives me an answer 97. And then because Y and Z lie on a straight line, those two angles need to add up to 180. So for Z, it's going to be 180 minus Y, which gives me an answer of 83 degrees. And there is my answers for all of those 6 angles. So let's now move on to our next circle theorem, which is the Acylic Quadrilateral. Now the definition is that opposite angles in a Acylic Quadrilateral is equal to 180. So here what we've got is that angles of A, D, C plus the angles of A, B, C add up to 180 because these two angles here are opposite. Then obviously also we know is that DAB plus the angle of BCD is going to be equal to 180 degrees as well. So in terms of this, all you need to remember is that opposite angles add up to 180. And again, if you're going to use this proof, you need to make sure that you're using that definition in your answer. So again, let's have a look at some example questions just to finish this one off. So again, looking at this, looking at A first, well, I know I can see a Acylic Quadrilateral, I can see a four-sided shape inside my circle. Let's just zoom that back up. So here, so this is opposite to angle Y. So to work out what Y is, it's going to be 180 minus 102, which leaves me an answer of 78 degrees. Then working out what X is, that's opposite this angle here, angle B, so that's going to be 180 minus 115, which gives me an answer of 65 degrees. Then working out with B, so let me just put a line through that. So here I've got to work out X, Y and Z. So again, looking at this, I'm going to work out what X is first. So again, this is opposite to angle C, so I've got to do 180 minus 83, which gives me an answer of 97 degrees. Now when working to find out angle Y, there's a couple of rules in which I can do. So I know that angle D or Y that I'm trying to find, it's opposite the angle of 108. So this angle and this angle here are going to both add up to 180 rather. So it's going to be 180 minus 108, which gives me an answer of 72 degrees. Now I could also have used that angles inside any quadrilateral add up to 360. So because I know what 3 of the angles are, so I know what angle A is, B is and C is, I could have taken that from 360 and I still should end up with the same answer. Now in terms of trying to find angle Z, well that lies on a straight line with Y. So if that's 72, then this Z is going to be 180, take away 72, which gives me an answer of 108. Then moving on to our last question, which looks very, very similar to question B, but let's just have a look through it. So again, working out the letters, I've got U, v, w, and x to find. And again, there's no particular order in which I've got to do this, but again, it's entirely up to you. So I'll start off with x. So angle x is on the same line as on a straight line with 121. So x is going to be 180 minus 121, which is going to give me an answer of 59 degrees. So this angle here is 59. Then to work out v, well, that's going to be opposite angle of angle x. That's going to be 180 minus 59, which is going to give me an answer of 121 degrees. Now, although none of these diagrams are ever drawn to scale, they would tend to have that an obtuse angle will look obtuse, a reflex will look reflex, and an acute angle will look as a acute angle. But again, I would definitely not get a protractor out for these particular theorems, because it should really say that none of these diagrams are drawn to scale. So again, going back to the question, so working out angle W, well, angle W is on a straight line with 98. So I'm just going to do 180, take away 98, which is going to give me an answer of 180 minus 98 gives me an answer of 82 degrees. So this is 82. And then to work out what angle U is, well, that's going to be 180 minus 82, which is going to give me an answer of 98 degrees. And there are my 4 angles. Now we'll put a copy of these questions in the description below along with some notes, and obviously these are only 3 of the circle theorems. I definitely encourage you to watch the next video on circle theorems 2, which covers the other theorems.